Hi everyone. Today we're going to study join and meet of 0-1 matrices. First, let us define 0-1 matrix. A matrix with entries that either 0 or 1 is called a 0-1 matrix. We have one example here, matrix A. Entries are 1, 0, 1, 0, 1, 0. Remember that a matrix is defined by m rows by n columns, or simply we write m by n matrix. In our example here, we observe that there are 2 rows, so this is the value for m. And then we have 3 columns, so we change the n into 3. So for our example here, we have 2 by 3 matrix. 0-1 matrices are often used to represent discrete structure, and they are based on Boolean operations or and the operation AND. Let us define now join and meet of 0-1 matrices. Let capital A equals small a sub ij matrix and capital B equals small b sub ij matrix be m by n 0-1 matrices. The join of A and B is the 0-1 matrix with ijth entry A sub ij or B sub ij, and it is denoted by A or B. The meet of A and B is the 0-1 matrix with ij entry A sub ij and B sub ij, and it is denoted by A and B. Let us see this example. Find the join and the meet of the 0-1 matrices. Matrix A 1, 0, 1, 0, 1, 0. Matrix B 0, 1, 0, 1, 1, 0. Take note that matrices A and B have the same size. Let's begin now with a join of A and B. This is denoted by the operation A or B. We're going to do OR operation to corresponding entries of the matrices. Remember that for OR operation, the value is always 1, except when both entries are 0. So we are going to write the join to be like this, A or B. For the first entry, this is 1 or 0, and this is equal to 1. Second, the 0 or 1 is 1. Third, 1 or 0 is 1. Next, 0 or 1 is 1. Then 1 or 1 is 1. Next, 0 or 0 is 0. So the join of A and B is the matrix 1, 1, 1, 1, 1, 0. Next is the meet of A and B, and this is denoted by A and B. Remember that for the Boolean operation AND, the value is always 0 except when both of the values are 1. So we write it like this, the A and B. For the first entry, we have 1 and 0 is 0. 0 and 1 is 0. 1 and 0 is 0. 0 and 1 is 0. 1 and 1 is 1. 0 and 0 is 0. So the meet of A and B is the matrix 0, 0, 0, 0, 1, 0. These are the final answers. Today, we're going to study Boolean product. Let us define Boolean product. Let capital A equals the matrix A sub ij be an M by K 0, 1 matrix, and capital B equals small b sub ij matrix be a K by N 0, 1 matrix. Then the Boolean product of A and B, denoted by this symbol, is the M by N 0, 1 matrix with ij entry C sub ij, where C sub ij equals the operation A sub I1 and B sub 1j, or the operation A sub I2 and B sub 2j, or up to the operation or the operation A sub ik and B sub kj. Note that this Boolean product is similar to multiplication of matrices, such that and operations correspond to multiplication and addition respectively. Let us see this example. Find the Boolean product of the 0, 1 matrices. Matrix A 1, 0, 0, 1, 1, 0, and matrix B 1, 1, 0, 0, 1, 1. For our solution, let us write the symbol of the Boolean product for A and B. Take note that matrix A is a 3 by 2 matrix, meaning 3 rows by 2 columns, while matrix B is a 2 by 3 matrix, which means 2 rows and 3 columns. Remember that in the multiplication of matrices A and B, the column of A must be equal to the rows of B. And then, for the product, the resulting matrix must be 3 by 3. It means the number of rows of A and the number of columns of B. This is the general form of the 3 by 3 matrix. Let us now solve the elements one by one. Let's begin with the first element, A sub 1, 1. We're going to consider the first row of A and the first column of B. So we write 1 and 1, or 0 and 0. When we simplify this, 1 and 1 is 1, and then the or 0 and 0 is 0. 1 or 0 is 1. Then A sub 1, 2. We need the first row of A and the second column of B. So we write here 1 and 1, or 0 and 1. The 1 and 1 is 1, or 0 and 1 is 0. 1 or 0 is 1. Next, A sub 1, 3. We need the first row of A and the third column of B. So we write here 1 and 0, or 0 and 1. 1 and 0 is 0, or 0 and 1 is 0. 0 or 0 is 0. Next element, A sub 2, 1. We need the second row of A and the first column of B. So we write 0 and 1 or 1 and 0. 0 and 1 is 0 or 1 and 0 is 0. 0 or 0 is 0. Next element, A sub 2, 2. We consider the second row of A and the second column of B. So we write 0 and 1 or 1 and 1. 0 and 1 is 0 or 1 and 1 is 1. 0 or 1 is 1. Next element, A sub 2, 3. We consider the second row of A and the third column of B. So we write 0 and 0 or 1 and 1. 0 and 0 is 0 or 1 and 1 is 1. 0 or 1 is 1. Next element, A sub 3, 1. We need the third row of A and the first column of B. So we write here 1 and 1 or 0 and 0. 1 and 1 is 1 or 0 and 0 is 0. 1 or 0 is 1. Next element, A sub 3, 2. We shall consider the third row of A and second column of B. So we write here 1 and 1 or 0 and 1. 1 and 1 is 1 or 0 and 1 is 0. 1 or 0 is 1. Third element, A sub 3, 3. So we need the third row of A and third column of B. 1 and 0 or 0 and 1. 1 and 0 is 0 or 0 and 1 is 0. 0 or 0 is 0. The Boolean product of matrices A and B is the matrix 1, 1, 0, 0, 1, 1, 1, 1, 0. This is the final answer. Today, we're going to study Boolean powers of 0, 1 matrix. Let us define Boolean powers of 0, 1 matrix. Let capital A be a square 0, 1 matrix and let R be a positive integer. The rth Boolean power of A is the Boolean product of R factors of A, as denoted by A raised to R. This A raised to R is equal to A multiplied to itself R number of times. Note that the A with power 0 is equal to the identity matrix. Let us see this example. Let matrix A equals 1, 1, 0, 0, 1, 0, 0, 1, 1. Find A power 3. Our solution begins with the computation of A power 2, and this is the Boolean product of A and A. We put this matrix together side by side. Since the matrix A is a 3 by 3, we expect our final answer to be 3 by 3 also. And the general form is here. Let's begin now with finding the first element, A sub 1, 1. We multiply the first row of this matrix and the first column of this matrix. So we write 1 and 1, or 1 and 0, or 0 and 0. Take note here that we have 3 pairs of AND operations and connected by OR. If we find a resulting value of 1 to any of these operations, then the full value here will be equal to 1. So 1 and 1 is 1, 1 and 0 is 0, 0 and 0 is 0. Because there is a value of 1 on this operation, the full operation here will be equal to 1. And that will be the value of A sub 1, 1. Here we go. Next, the A sub 1, 2. First column of this matrix, second column of this matrix. So we write now 1 and 1, or 1 and 1, or 0 and 1. Again, if any value of 1 is here, the full operation is equal to 1. 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0. So we see here a 1 value in any of the 3 pairs. So the full operation here is equal to 1. That is the value of our A sub 1, 2. So we write it here. We're going to follow this pattern in all our elements. Let's go for A sub 1, 3. A sub 2, 1. A sub 2, 2. A sub 2, 3. A sub 3, 1. A sub 3, 2. A sub 3, 3. So we have now the resulting matrix of A power 2. Let us write this answer on top of our screen. Now let us proceed for the A power 3. We can write this as A times A times A. This A times A is the A power 2, and we solved it a while ago. And this is the matrix. So we write this matrix multiplied by the matrix A. So let us multiply the two matrices. The first element here is 1 because we multiply this row by this column, and we write the row solution in here. The second element is 1 as we multiply this first row and the second column. Third element is 0. We multiply the first row by the third column. The next element here is 0. We multiply the second row by the first column. The next element is 1. We multiply the second row by the second column. Next element is 0. We multiply the second row by the third column. Next element is 0. We multiply the third row by the first column. Another element is 1. We multiply the third row by the second column. The last element is 1. We multiply the third row by the third column. This is now the A power 3 matrix. This is the final answer.